Hey, this is Miss Baker, and we are talking about the unit circle. We are going to try to derive where all of our degree measures, our radian measures, and our coordinates come from. This is probably going to take more than just this one video, but I'm going to go ahead and get started here. If you missed school on Wednesday before spring break, you definitely need to watch this whole video. You can also come and get your own blank unit circle from me. So we already know some of the degree measurements. This is obviously 0 degrees. If we go to the end of our first quadrant, it is 90 degrees. If we go to the end of our second quadrant, we're at 180. If we go to the end of our third quadrant, we are at 270. And then all the way around is 360 degrees. In the middle, I'm going to use a different color. Hopefully you can see the middle of all of these. It's going to be right here. The half of 90 is going to be what? 45. And so we're going to count by 45s. 45 plus 45 gives me 90. 90 plus 45 is going to give me 135. 135 plus my other 45 takes me to 180, plus another 45 is going to be 225. We're down to 270 and then back around to 315. So those are my 45-degree angle measurements. Oh, sorry. And then after we have our 45s, the next division that we're going to have, if you can actually see, there are 1, 2, 3, 4, 5, 6. One of my students liked it when I did this in the last class. 1, this is the second, this is the third, this is the fourth, this is the fifth, and this is the sixth part of the circle. See how that's divided out? All right, so now if we divide 180 by 6, how many degrees is that? 30. So this is going to be 30. You add 30 more, we get to 60. Then that takes us to 90. Plus 30 is 120. Plus another 30 is 150. Down to 180. Plus another 30 is 210. 240. 270. 300. 330. And 360. From here, we are then going to talk about our radian measure. Radian measure we started yesterday, and we said we can start with 0, and what was an entire circle all the way around? That's 360 degrees. In radian measure it was 2 pi. So in radian measure we are starting at 0 and we are going all the way around to 2 pi. Now if this is 2 pi, what's 180 going to be? It's half of it. So it's going to be pi. And then 90 degrees is going to be half of that. So you can say 1/2 pi, but we normally write it as pi over 2. We typically refer to that in mathematics as pi over 2. This is 0, 1/2, 2 halves, right? Because 2 over 2 is 1. So what is down here going to be? So 3 pi over 2. And 3 pi over 2 then turns into 4 over 2, which is the same as 2 pi. From here, we're going to talk about our 45 divisions. I'm going to go there next. Half of a half. If I have half a pizza and then I cut it in half, how much do you have? A fourth of the pizza, right? So this is actually going to be pi over 4. 45 degrees is going to be pi over 4. I think that actually was one of your homework, something like one of your homework problems. So pi over 4 is 45 degrees. This is 1/4. My 2/4 is going to be up here, right? Because 2/4 is the same as 1/2. What is 135 going to be? 3 pi over 4. 135 degrees is 3 pi over 4. This is 4/4. Go again, this is going to be 5 pi over 4. Another fourth will take me to 6/4, which is the same as 3/2. And 315 degrees is going to be 7/4. 7/4. My next would be 8/4, and of course 8/4 is the same as 2. Now we already said that we have divided in order to get our angle measurement. Do you remember how many divisions I said for the blue? Anybody remember how many times we divided it? 6, right? 6. So one of those divisions, 30 degrees, that was one of your homework problems. 30 degrees is going to be pi over 6. That's 1/6. Then we are going to move to 2/6. The reason I didn't write 2/6 is because what does 2/6 simplify to? Pi over 3. So we're going to have pi over 6, pi over 3. My 3/6 is, what's 3/6 simplify to, guys? 1/2, so I don't need to write that again. This is 4/6. 4/6 is going to simplify to 2 pi over 3. Thank you. And then after 4/6 is 5/6. 6/6 comes next. 7/6 comes after that, so this is going to be 7 pi over 6. 8/6 comes next. I'm not going to write 8/6 because what is 8/6 simplifying to? Be careful. 4 pi over 3. 9/6 is going to simplify into 3 over 2. 10/6 is going to simplify into 5 pi over 3. And then 11 pi over 6 finishes us up at 330, which takes us back to 12/6. And 12/6 is 2. So far we have done the angle measures in degrees, and we have done the angle measures in radians. On Friday, you are going to be responsible for both of those on your quiz. You are going to be responsible for knowing all your angle measurements in degrees and all of your angle measurements in radian. There are some people who are like my husband who can just sit and memorize something, just works. Actually, he normally hears it and it sticks. And then there are some people like me who need the pattern, and so that's why I wanted you to see. This is my 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6, 9 6, 10 6, 11 6, and 12 6. So whichever way works best for you, you're going to have to memorize that relationship. Okay? Now, we have coordinates that we are going to have to learn as well. As you can see, there are space, comma, space all the way around. The coordinates are what we are actually going to use when we are trying to come up with our sine, cosine, and tangent curves that we have to graph. The coordinates are in the form of x, comma, y. And we said that this is our unit circle. So our unit circle has a radius of 1 unit. This is our origin, and if we go out to the side of the circle, that distance is going to be 1. So the coordinate right here, if we go out 1 and don't go up and down, is going to be 1, 0. 1, 0. The coordinate up here, we don't go left and right, so my x-coordinate is 0, but we do go up 1. So this coordinate is 0, 1. Over here, my coordinate is -1, 0. And then down, my coordinate is going to be 0, -1. So hopefully that gets everybody on the right track with the 4 main coordinates. Now, our other coordinates are actually going to use something that you learned back in geometry in order to find your measure. A long time ago, many, many moons ago, you talked about 45, 45, 90 triangles. Anybody remember that? 45, 45, 90? 45, 45, 90 triangles have a particular relationship. The sides are always, always, always in the exact same ratio. Anybody remember what that ratio is? Close. You're on the right track. Huh? No, you guys don't need to draw this. I'm just going to explain to you where your coordinates come from, okay? Well, that's your Pythagorean theorem. But if you know that you have a 45, 45, 90, then your sides are in the ratio of 1, 1, square root of 2. Anybody remember that? You've seen it before. Every time you see a 45, 45, 90, your sides are going to be in the ratio of 1, 1, square root of 2. Now, if this side right here is 7, then this is going to be 7, and this is going to be 7 square root of 2. If this were 6, this side would be 6, and your hypotenuse is going to be 6 square root of 2. But we have a hypotenuse of, what's my radius again? 1. This is a unit circle. We have a radius of 1. Yes. So if we are trying to figure out how to make our relationship with a hypotenuse of 1, then we need to solve the equation, the square root of 2x equals 1.